This is a nice lesson to arrive at. We are at number 11 of the 11 lessons we were going to do in this unit. And in this lesson, we're going to stick right here. Actually, we're going to go back to that. We have had a couple sessions on creating models using trig functions. This, of course, was my favorite part of it. But just so we don't forget about cosecant, oops, how about spelling it? I guess maybe I already forgot about it. Cosecant, secant, and cotangent. These are reciprocal partners of tangent, cosine, and sine. So we're going to take a look at these graphs one more time before we move on into Unit 5. This will be a fairly short lesson. You don't mind that, do you? Cosecant. Okay, we know this is the ratio of the radius to the vertical. It's a reciprocal partner to sine. So now y is in the denominator, so every time that y is equal to 0, as here, it's right here and here, happens once in every period, well, twice, happens at the beginning, midway, and then again at the end, and as you go around, it happens twice in each period. So we remember that when we very first learned these, we learned it in terms of the hypotenuse, which is now called radius, and the opposite, which we now refer to as y, cosecant. Secant, we have a similar situation here. This is the reciprocal partner of cosine. So we've got x now has moved into the denominator. So every place where x is 0, which happens at 90 degrees, and again at 270, you're going to have an asymptote. So it starts from 0 high, well, I shouldn't say that. It did when it was a cosine. But now we're talking about the reciprocal of that. So it starts okay at 1 and then goes to 0 and then builds back up and then goes back to 0. So this is, we're talking about the denominator. Twice in every full rotation or every full cycle, you're going to see that asymptote. So the hypotenuse is now the radius. The adjacent is our x. Just to remind ourselves of domain and range for each of these. The domain for cosecant is everything except these asymptotes where y is going to 0. And the range, that's all numbers except those that have been consumed by sine. Now they do share some points in common, don't they? They share, whoop, let me get my pen. They share this point and this point, and I can't hardly see it, but it's over there, that point and that point. They share the peak and the valley. That's something they have in common. But other than that, it's all numbers are excluded. And for secant, it's very similar. They share the peak and the valley, that specific point, and everything else is excluded from the range. We're going to spend some time now looking at tangent. We really have done very little with tangent. We know its definition. We started with SOHCAHTOA, opposite over adjacent. And of course its reciprocal partner, cotangent, which is adjacent over opposite. Now obviously these are going to have asymptotes, because every time x goes to 0 you're going to see an asymptote. So for tangent, it starts out okay at angle 0, but as soon as we get to 90 we have an asymptote. Then we get a full cycle going from negative 90 to positive 90, and we get another full cycle when we go from 90 to 270. So we're going to, in a full rotation, see two full cycles. We know that the period for the tangent function is pi. And for cotangent, in this one, we have an asymptote wherever y is equal to 0. So we're seeing cycling, and it's going in the opposite direction of from very high to very low, happening twice in a full rotation. And this is from 0 to 180. We see the first cycle, and then from 180 to 360 the second cycle. Here's what it looks like graphically. Let's emphasize our y-axis. I think that'll make sense here. We see here just what we talked about, from an asymptote at negative 90 to an asymptote at 90, and then repeating in the next pi. For cotangent, our asymptote is at 0, and it comes from high down to low, and it's completed its cycle by the time it gets to pi. Okay, so the domain, all real numbers except those at the asymptotes, and the range on this one, no limit on the range, so all real numbers, all real numbers. Develop a table of values for cotangent t. Now I want you to take a moment and put this into your notebook. This is something you're going to complete in class. I'm going to ask you to do this by hand. I know this shows what we would use on the calculator, and we can verify it on the calculator, but I want you to figure out your points for tangent and cotangent, and then graph your cotangent, okay? And we're going to work in radians, and also in mode you want to go from connected to dot mode. Okay, so you can work on that in class. If you have any questions about it, I'll help you in class. Before we leave, now that I know how to pronounce period, oh no, I'm not going to have trouble with it, am I? Periodicity, periodicity, periodicity. I couldn't resist putting it up here again. This is just to remind us that the period for sine and its reciprocal partner, 2 pi, for cosine and its reciprocal partner, 2 pi. And just to make things interesting, the period for tangent and cotangent is pi. I think we've seen this slide before, haven't we? It's just making note of where the asymptotes fall. And when you do your graphing, you're going to represent those with dashed lines. So back here where you do cotangent, by the way, you're working with the parent here. This is the parent function, the simplest possible one. So you could, at the very beginning, draw in your asymptotes. There's no phase shift here. So you could draw those in where you know they belong. For cotangent, I don't actually show this one over here, but it should be shown. It should be showing one there. I should fix that. 180, 360, every pi. Done in 12 minutes, or a little longer if you had to pause for something.